So we saw that functions behave like vectors, but you also notice in this class we talk about polynomials a lot. Polynomials are functions, at least the way we talk about them they are, and the reason we like polynomials in this class is because it's easy to find a basis for the polynomials. Functions in general are infinite dimensional vector spaces, and so we don't deal with those in this class. In this class we deal with finite dimensional vector spaces so that we can have a finite set of basis elements, like the monomials. So multiplying a fixed polynomial by a polynomial is a linear transformation. The particular example that's on the handout is multiplying by the fixed polynomial 1 plus x. And to see that, I've written out the outline of the proof. We would have to start with, let's take this linear transformation and do it to the sum of two polynomials. And notice I'm only doing half of the proof here because I'm hoping that by now, or I'm expecting that by now, you can do the other half of the proof. Or even do it in one step instead of just half and half again. So we have to, in order to add two polynomials together, we need to define them or create them. And so so we say let P1 and P2 be two polynomials, and we specify that they are degree up to n. So for some n. So now that we've created two polynomials, we can add them together and multiply by 1 plus x and see what happens. What happens is that we have the distributive property for polynomials, and so 1 times those two things are those two things, and x distributed to those two things are these two things, xp1 plus xp2. Notice that these are that multiplying by x adds 1 to the degree of a polynomial. Multiplying by x adds 1. So if they were degree n, if there was an x to the n term, times x would make it x to the n plus 1. So these could be degree up to n plus 1. Here's another example where the input space to a linear transformation is a different space than the output space to the linear transformation. By necessity, this has to have one extra dimension from this one. For this particular fixed polynomial, note we could have picked any polynomial and it would have been a linear transformation between two different polynomial spaces.